So in section 6.4, we're going to break this up into two parts. The first part we're going to break up and we're going to focus on factoring and solving, and then on the second part that we're going to do on Monday, we're going to focus on kind of the other piece of complex roots and things like that as we work through here. So this is just a review, this first piece of what we've done so far this chapter with factoring. And I really just worked them out completely. You realize that when you're given a polynomial, you can factor it completely. And so here's my first one that I did, and I took out the GCF here of the 3x from our line after I brought the 9x over. Obviously you need to set it equal to 0. And then I factored what was remaining because it's a minus at the back. We have a minus and a plus. And then I set each factor equal to 0. Now this is something that we need to kind of focus on. A couple of us stumbled a little bit on the quiz. When you have a 3x there, you need to set that equal to 0, and that's one of your zeros. So a couple of us didn't, we factored, but we didn't take into consideration that x equals 0. So we got to make sure if you have 3 factors, you have 3 zeros. So over here, I brought the 48x over. I took out a 6x. So 6x equals 0 and x minus 8 equals 0, so we have 2 answers. Now you could have done each of these problems by using your calculator as well, graphing it and finding the zeros. I'm not sure which way is faster sometimes. If the problem is simple, it might be simpler to factor it and solve. But the problem has a decimal max, 3.1729, then it's not going to be as easy to do with factoring, obviously, and then graphing is going to be the fail-safe method. So I just want to have you remember you can always solve an equation by graphing, but it's not as fast. And you're not guaranteed what the answers are going to be. So we have that as an option. But I just kind of push past that for today, and I want to talk about how we factor some very unique things. And when we have some unique pieces where both terms are cubed, we have a very unique situation. And so I have in green here the formula for the sum of 2 cubes. So if it's a cubed plus b cubed, it ends up being the factors of a plus b as the first factor. And then the second factor is kind of unique. It's a squared minus ab plus b squared. And then the difference of 2 cubes, over here, we have a cubed minus b cubed becomes a minus b, and then a squared plus ab plus b squared. And the way I remember this is a really dorky way, but it works. And you know the baseball team, hopefully the San Diego Padres, okay, out in the West. And those letters, San Diego Padres, help me remember the first term has the same sign. So notice the plus here and the plus there. When I say the same sign, I mean they're both pluses. And then the D of San Diego Padres stands for the second part has a different sign. So if the first one is a plus, then different than a plus is a minus. And then the third one always has a positive sign, so here's a positive. So let's look at the back one, a squared, a cubed minus b cubed. The first one has the same sign, a minus, then different, then a positive. And so that's just a pattern that we're going to need to memorize as the sum and difference of 2 cubes. And if it helps you remember same sign, different sign, positive sign, do that. If it helps you remember the San Diego Padres, do that. But either way, you're going to need to memorize that sum and difference of cubes formulas. Without them, you will end up stumbling extensively as we come across these problems. And you're asked to factor them, because there's no way to factor them unless you know this formula. So that being said, I want to really encourage you to remember it. You could long divide it if you happen to guess the factor, but that would take you a very long time versus doing that. So down here, Aaron, at your request, I tried to be as inclusive as I could. Right now we're going to focus on the purple, and we're going to practice factoring the sum and difference of cubes, and we're going to follow that formula pattern to factor them. And then later in blue, we're going to take the second half of our lesson today, and we're going to take that second piece and we're going to solve. So I'm going to slide up intentionally, which causes our formulas to disappear. And let's see if we can reproduce our formulas right now without looking back. A cubed plus b cubed. Do you remember what the first factor is? Remember, same sign. So what's it going to be? A plus b. And then the back half is a squared, an ab in the middle, and a b squared at the end. So remember, same sign. What's the next one? Different sign. And what's the back one? Positive. Okay, now let's do the other one. Over here, a cubed minus b cubed. First one, remember, once again, is same sign. And then at the back, we have a squared, ab, b squared. Remember, same sign. What's this one become then? The different sign and a plus. So those are our formulas. And so let's take a look at what we have here. X cubed plus 8. This is really x cubed plus 2 cubed. What are we cubing? X and 2. That's our A and our B. So once you do your identify what your A is and what your B is, then you can cube. So let's just write this in factored form. X plus 2, x squared minus 2x plus 4. And we're done. And once again, that's a plus b, a squared minus ab plus b squared. That's where that came from. A is x, b is 2. And I just plug them into the formula. That's it. So memorizing that formula is going to be fairly critical as you're thinking through this stuff. I would encourage you to write those formulas at the top of every page or every problem until you've got them really, really well memorized. It might be easy tonight, but remembering them for next week or the following week or as we move forward to the next chapter or whatever, you need to kind of keep these in your mind. Very, very straightforward. Let's. A plus B?
Yeah, should be.
No, because this is the factored form of this up here. Because a times a squared is a cubed. All right, let's look at the second one. We have 27x cubed. What times itself 3 times equals 27? 3. So I suggest you rewrite this as 3x, the quantity cubed. What times itself 3 times equals 64? 4. And so my A is 3x, my B is 64. Or sorry, my B is 4. So I'm going to write my formula, A minus B, A squared plus AB plus B squared. And I think that's going to help you as you work these kinds of problems out. So now let's just fill in our values. What is A? 3x. Minus, what is b? 4. What's 3x squared? We're taking the 3x and we're squaring it. So what do we get? 9x. Plus, what's 3x times 4? 12x. And then what's 4 squared? 16. That's it. Yes, ma'am. Sorry, I forgot the squared. Thank you. I got so wrapped up in just going to the next step that I forgot the squared. So if you remember the formula, it's going to just slide right in just like that. Questions there? Good morning, Paul.
How do you get 4?
I said to myself, what cubed, something cubed equals 27. And then also, something cubed equals 64.
Will it always be cubed?
Mm-hmm. Okay, so obviously those are our 2 answers. We'll circle them in green. There's our first one, and there's our second one. So, factoring perfect cubes. Hopefully that's pretty straightforward. Let's look down at the bottom one. Part 2. Do you remember our formula, the quadratic formula? X equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Remember that from Jack in the Box? Okay. We use the quadratic formula to solve things that are unfactorable. So we might have to use the quadratic formula on some of our problems in the second piece. And then the second thing I want you to remember of is square roots of negatives, Cole. Remember how those are imaginary numbers from semester 1. So I gave you an example over here, like the square root of negative 12 is really the square root of negative 4 times the square root of 3. And this negative comes out as an I. The 4 comes out as a 2. And so we can reduce the square roots of negatives using complex and imaginary numbers. So just as a reminder, those two little pieces pulling back from our memory banks from semester 1. So let's take a look at this problem then with regards to not just what the factored form is, but what the final answers are. Where do they cross the x-axis? And so here we go. We're going to practice again. This is a cubed minus a cube. So we have x cubed minus 2 cubed. Let's write the formula as practice. Here we go. A minus b, remember, same sign, different sign, and positive. And I think if you write that problem down each time we're doing our homework, by the end of the homework assignment, you'll know the formula. I would really encourage you to do that. So let's fill them in. X minus 2. X squared plus 2x plus 4 equals 0. Pause for a second. Cole, any questions? Does it make sense? How many factors do I have? 2 of them. Now here's the issue. This first one, x minus 2 equals 0, is easy to solve. Boom. X equals 2. That means, Paul, it crosses the x-axis at 2. The second one, does anything multiply to 4 that adds to 2? Well, the multiples of 4 are 4 and 1, that adds to 5, and 2 and 2, that adds to 4. So the problem B is nothing factors to solve the second one. That's why we're going to have to do the quadratic formula. So let's jump to the quadratic formula. X equals the opposite of 2 plus or minus the square root of b squared, so that's 4, minus 4 times 1 times 4, all over 2a. So once again, that was a was 1, b was 2, and c was 4. Quadratic formula. So let's solve our quadratic formula here. Negative 2 plus or minus 4 minus 16 is negative 12, all over 2. And actually, without even thinking about it, I didn't realize that was our practice problem. But what's the square root of negative 12? It breaks down into the square root of negative 4 and the square root of 3, all over 2. So negative 2 plus or minus 2i square root of 3, all over 2. And I'm trying to show each step of the problem without skipping things as I might do if I were doing it on my own. Look outside. I'm going to highlight here for us as a reminder. We look at that number, and that number. Are they all divisible by the same thing? If they are, we can reduce. So I'm going to write this in red at the bottom because this will be our answer. Negative 1 plus or minus I root 3, and x equals 2. If we were to graph this problem, Catherine, we get the cubic function, it would cross at 2. But it wouldn't cross 2 more times because the other 2 answers are imaginary. And if you remember back to semester 1 when we had imaginary answer, remember we had a parabola that didn't cross the x-axis? That's an imaginary number. And so this has 3 answers. One of them is real, the number 2. The other 2 answers are complex, and those answers are negative 1 plus root I root 2, I root 3, and negative 1 minus I root 3. So we still have 3 answers, but some of them are going to be imaginary. So it's okay, perfectly fine, but what's in red there at the bottom are our 2 answers. And this is where we're starting to use those complex numbers to our advantage. Let's try this last one. X cubed. What cubed is 125, folks? 5 cubed. All right, so here we go. I'm going to write my formula. A plus B. A squared. Is the next one going to be plus or minus? Minus, because it's a different sign, Kent. So minus AB. And then the last one, remember, always is plus. And so that equals 0. So let's fill them in. X plus 5, x squared minus 5x plus 25 equals 0. The first one's super simple to solve. X plus 5 equals 0, x equals negative 5. A equals 1, B equals negative 5, C equals 25. I know some people like it when I write those out for the quadratic formula. So here we go. X equals the opposite of negative 5, which is 5, plus or minus negative 5 squared, which is 25, minus 4 times 1 times 25, all over 2a. So 5 plus or minus 25 minus 100 is negative 75, all over 2. Christian, what perfect square goes into 75? Come on. If you got some money in your pocket and you had a quarter, that's 25 going to 75. Yeah? Okay. So 25 goes into it. So I've got square root of negative 25 with the leftover square root of 3 all over 2. And the square root of negative 25 is 5i. So x equals 5 plus or minus 5i root 3 over 2. Once again, I'm going to look at these 3 numbers. Do all 3 of them divide by anything? No, not in this case. So I can't go any further here. So now I look back at my original answers, and my answers are x equals negative 5, x equals 5 plus 5i root 3 over 2, and x equals 5 minus 5i root 3 over 2. So we've got multiple different answers there. These 2 back answers are viable answers, but they don't cross the x-axis. But they're still answers. It's just they're called complex because they have i's in them. That's it. All right? So let's kind of go back now and let's take a look at our formula and see if that makes sense with our instructions. Once we have the 2 portions, we set the first factor equal to 0 and solve. The second factor is solved using the quadratic formula by by graphing and giving the answer to the nearest 3 decimal places. Now the problem is, Simon, if it doesn't cross the x-axis, then we're going to have to use the quadratic formula. So we're going to have 3 potential answers. Sometimes answers are duplicated, so they're not going to happen. You might have x equals 0, and x equals 3, or something like that. So remember our formulas with the San Diego Padres, same sign, different sign, positive. So there's the SDP idea. And then just general factoring at the very beginning. Like you guys have asked, once again, we've got our problems down here for you. Make it nice and easy for you. Pretty short, 12 through 20 all. Very doable, I hope, as we work through these. So, that being said, let's try to knock this out.